So, good morning, all. Myself, Naveen Prasad from Vellore College of Engineering and Technology. So, today I'm going to discuss few basic concepts on heat transfer and mass transfer. I'm going to completely deal about the basic concepts of heat transfer in the today's session. So, first we move into the basic concepts. First, we have to know the basic difference between the heat and the temperature. So heat is nothing but the amount of energy which will flow from one body to the another body. For example, the heat will flow from higher region to the lower region. So it is the degree of hotness or coldness. Right? So the temperature will flow from higher temperature region to the lower temperature region, and so unit of heat is, we can say it in as calories or joules. So heat is nothing but it is the degree of hotness or coldness. Temperature is nothing but it is the measure of heat. For example, if you are measuring the hotness or coldness of anything, so using some external device, for example, the heat measuring device, so it is called the temperature. If the degree of hotness or the coldness is measured using some temperature measurement device, it is called the temperature heat measurement device, right? So it can be measured in terms of in the degrees of Celsius, Fahrenheit, and in also in Kelvin. So, for example, if we have a cup of coffee, we may feel some amount of hotness when we put our hand into the around the coffee cup. We can feel some amount of hotness, right? So it is called heat. So if the same heat is measured using some measurement device, it is called the temperature. So the basic of thermodynamics and heat transfer. So the basic difference between the thermodynamics and heat transfer is that it will deals with the relationship between heat and other forms of energy, right? So the thermodynamics, actually with the help of heat, the heat will be converted into other forms of energy, but in thermodynamics, but in the heat transfer, so we are going to analyze the rate of heat transfer. So in thermodynamics, so the heat will be converted into other forms of energy, and in the heat transfer is going to completely deal with the analysis of the rate of heat transfer. So what is heat transfer? So heat transfer is a science which deals with the rate of heat transfer occurs. The same way, the mass transfer is nothing but the science which deals with the rate of in which the mass transfer is occurs. The applications of heat transfer are, so even the human body. So the human body is rejecting the body to the surroundings. It is a best example. And in the household applications, we are using TV, computer, refrigerator, freezer, water heater, etc. So even though air conditioning system, etc., it is in the which is used in the household applications or the application areas of heat transfer. And even though we have the major role in the design of many other devices such as the car radiators, solar collectors, various components of power plants, and even in the spacecraft. So engineering heat transfer. So what is the engineering heat transfer? So in the engineering heat transfer, you are going to study the temperature distribution and the heat transfer with a greater importance. So the engineers need to calculate the temperature distribution and the heat transfer in the universal occurrence in many other branches of science and engineering. So in the engineering heat transfer, we can analyze the or study the heat transfer in two methods. One thing is experimentally, and another thing is the analytically. So experimentally is nothing but by testing and taking measurements using some devices. Analytical approach is nothing but by using the analysis or calculation. For example, we are going to calculate how much of heat transfer occurs in mathematical model. So in the experimental approach, we are going to use a physical system, and we are going to measure the temperature in a system. So it may be cost. It may be expensive in cost, and it consume some amount of time, and often it is some import impractical. But in the analytical approach, we can solve the problems as much as fast, and also it is inexpensive, and the results which we got is will be accurate to the assumptions. So before going for the experimental approach, we can go for the analytical approach. It will be very much useful, and also it will consume less time, and it will be inexpensive. So next we are going for the mechanisms of heat transfer. So to totally we have three mechanisms of heat transfer. It is also really three modes of heat transfer. So nothing but conduction, convection, and radiation. So conduction is nothing but heat transfer occurs between the same medium. For example, solid to solid, liquid to liquid, and gas to gas. Convection is a mode of heat transfer in which the heat transfer will occur between two different mediums. For example, solid to liquid, liquid to gas, or gas to liquid, or gas to solid. So radiation is nothing but electromagnetic waves. So the modes of heat transfer is accomplished by two mechanisms. One thing is the molecular interaction between the molecules. So the molecular whereby the energy exchange takes place due to the kinetic motion or direct impact of molecules. Molecules at relatively high energy level impart energy to adjacent molecules at lower energy levels. So it can take place in solids, liquids, and also in gases. And the second mechanism is by the drift of free electrons in the case of metallic solids. So let me see the three modes of heat transfer. So first thing is the conduction. So conduction is the flow of heat in a substance due to exchange of energy between the molecules. So which have the higher energy, and molecules having the lower energy. So conduction, as we already said, the conduction takes place in solid, liquids, and gases. The best example is conduction takes place between the same medium, for example, solid to solid, liquid to liquid, and gas to gas. So there are two ways the conduction will happen. One thing is the conduction occurs in solids in two steps. One thing is the lattice vibration of molecules, and next thing is the flow of free electrons. And also the conduction occurs in liquids or gases. So in the liquids and gases, the heat transfer will occur due to the collisions of molecules in random motion. So the rate of conduction mainly depends upon rate of conduction through a substance mainly depends on so the geometry of the medium, so its thickness, material of the medium, and temperature difference across the medium. So before moving into the convection part, let us discuss about the steady state versus the transient heat transfer. So what is steady state? So in the steady state heat transfer, the term steady implies there is no change with time at any point within the medium. For example, let us consider a wall. So if a wall, the outer surface of the wall let us consider the outer side of the wall is 15 degrees Celsius by 2 p.m. and the inner side of the wall will be 7 degrees Celsius at 2 p.m. After few hours, for example, the time is measured, the temperature measured it at 2 p.m. At 2 p.m., the outer side of the wall is 15 degrees Celsius, and the inner wall is 7 degrees Celsius. After 3 hours, for example, at 5 p.m., it seems the temperature constant at inner side and the outer side of the wall. So here the heat transfer from at 2 p.m. is equal to the heat transfer at 5 p.m. So Q1 is equal to Q2. So it implies that in the steady state heat transfer, there is no change with time at any point within the medium. So next thing is the transient heat transfer. It is also called the steady state. is also called the steady state. So the temperature, the it will be in the temperature will variation with time or time dependence. So for example, at 2 p.m. we can see that 15 degrees Celsius at the outer side of the wall, and inner wall is 7 degrees Celsius, and 5 p.m. it will be sure it will be differ. So from this we can say that Q1 is not equal to the Q2. For example, best example is if you are having an apple, right? So apple in a refrigerator, I'm taking the apple from the refrigerator and kept it in over the atmospheric pressure. Okay, so at 2 p.m. the apple will be at, for example, the apple from the refrigerator. When I'm going to take the apple, the temperature is about 4 degrees Celsius. After few minutes or few hours, we can see the temperature will be then of an apple will be equal to the room temperature. So it depends upon the time as well as the position. So at 2 p.m. the temperature of the apple seems to be 4 degree when I'm taking the apple from a refrigerator, and after few hours I'm just measuring the uh, temperature of the apple. It seems more than 4 degrees Celsius. So the temperature Q1 is not equal to Q2. So because it variation with, because the heat transfer will be variation with time. So Q1 is not equal to Q2. So next thing is lumped system. So in the lumped system, the heat transfer will be varied with time, but not with the position. So the temperature of the medium changes uniformly with time. So for example, in a small metal object such as the thermocouple junction or a thin copper temperature can be analyzed as a lumped system during heat or cooling processes. So next thing is convection. So convection is nothing but heat transfer between the two different mediums. For example, solid to liquid, liquid to gas, or gas to solid. So the rate of heat transfer of energy from one region to the another region due to the macroscopic motion in a fluid added to the energy transfer by convection. So the energy transfer in convection will be happen due to the heat transfer between a surface and a moving fluid moving over it. So it is comprised of two mechanisms. The convection heat transfer is comprised of two mechanisms. One thing is energy transfer by random molecular motion, and another thing is energy transfer by the bulk or macroscopic motion of the fluid. So it is also depends upon the geometry and the roughness of the solid surface in addition to the type of fluid flow. So next thing is the laminar flow, turbulent flow, and transitional flow. So laminar flow is nothing but the fluid motion will be in the form of smooth layers and in a highly ordered motion, fluid motion. Turbulent flow, the fluid motion will be highly disordered. So which occurs due to higher velocity and due to the velocity fluctuations. So it is called the turbulent flow. And transitional flow is nothing but which is the combination of both laminar flow and the turbulent flow. So convection heat transfer can be classified into two types. One thing is the forced convection and another thing is natural or free convection. So forced convection is caused by the external means such as fan, pump, or atmospheric winds is called the forced convection. So in the free convection, there will be no external devices to transfer the heat. So it is mainly due to the buoyancy forces, which is caused due to the density difference by the temperature variations in the fluid. So when we are riding a bike, the air will be flow opposite to our ride. So it is called forced convection. And if you are sitting under the fan, when this fan is in on position, so it is an forced convection. So natural convection means when we are keep our bike outside and there is no external means, the heat transfer will be slowly gradually decreases in the heat from the engine. So it means there is no external devices to cool the engine for in only in the bike engines. Okay, so it is called the natural or free convection. So in the next session we can discuss about the radiation. Thank you.